We left off in session 1 covering how the index is put together and how targets are set, and how also within these major components of the school index this overall score comes out, and how the weights are redistributed if you do not have graduation or English learner components. So this is the typical example for elementary and middle schools, with 43% on growth and about 37% on proficiency. In this particular session, we are going to dive into the summative proficiency component and look at specifically how this 75% value came up within the index. And you'll remember from session 1 that that does not mean that 75% of students are proficient. That means that there was a target set and that this school met 75% of the target set by the state. You'll probably liken this proficiency to the dashboard, which actually combines all subjects: ELA, math, science, and social studies. And when you look at the dashboard at this sample K-8 school, you'll see that 50% of the school was proficient. That of similar schools, 42% of similar schools were proficient, and the state average is 36%. That's a 36% state average for a K-8 building in ELA, math, science, and social studies. The state average in math is actually 37.5%, so awfully close. ELA is a bit higher, science and social studies is a bit lower. And you'll notice that this state average is based on grades 3 through 8 and 11th grade. So instead of setting the target at the state average, MDE ranked all the schools and found that the school at the 75th percentile had 47.5% of the students proficient in math. That means that 75% of schools in the state of Michigan have a lower percentage than that 47.5. So the state target was set at 47.5%. Now what's odd about this is that third grade already met that target just by the state average of third graders within our state. So a building containing third grade is actually at an advantage when it comes to mathematics about scoring higher on the index. A similar pattern is found on ELA, so if we switch to ELA, we see that the state average for ELA is a bit higher. It's 49%. 75% of schools are below 60%, so the state target was set at 60%. And in this case, you'll notice the advantage goes to high schools, where the average 11th grade student, 60% have already met the benchmark on the SAT, and they're actually already meeting the state target. The second highest would be 5th grade. So again, the school index is going to give advantage to elementary buildings that contain a 5th grade and high schools that contain the 11th grade. So since math was advantageous in 3rd grade, and for ELA it's advantageous to have a 5th or an 11th grade, we see that the system has its benefits for elementary and high school, and that middle school is the typical grade span that is most disadvantaged by the overall state targets set using all grades. Looking back at the data that you mostly downloaded, you'll see once again that there is no such building code as 10, since we're getting all not applicable and 10, but that's where I put the fake data for the K-8 building. I did some rounding in the weights there, so it doesn't look like your typical building, and you'll see that it doesn't add up quite exactly the way that it should. But again, this is just fake data, and this is for demonstration purposes only. But what we want to dive into is this summative proficiency, and you'll see, as we covered on the previous 2 slides, that the ELA target is 60% and the math target is 47.55%. And of course 75% of schools are not going to meet these targets. This here is an example of a school that did not meet the target. They had 51% of their students that were proficient, but the system is going to inflate that score because instead of reporting 51%, we're going to report that they had 51 of the 60% target, or they had 85% of the target itself. Now, in most of your schools, you're going to have an equal number of ELA and math students. However, MDE will actually weight this differently if you have more math students than ELA students who take the test. So, for example, if there's 510 students that took the math test and only 490 that took the ELA test, then math is going to have 51% of the weight and ELA is only going to have 49% of the weight when we look at the percentage that met the target. So if ELA has 75% that met the target and math has 80% that met the target, math gets a little bit of the advantage because they have more students. So the overall proficiency index in this example provided by MDE is 77.55. What I find odd is that we weight the content based on how many students take the test, but subgroups are not weighted by how many students are in the subgroup. To give you an illustration on how this might be problematic, imagine a school has 3 subgroups, and there's a total of 280 students where 50 are not proficient. So we have 230 out of our 280 students that are proficient, or 82%. Each of these circles represents 10 students. So we have 10 that are proficient, 20 that are proficient, and 10 that are not. So 67% of students are proficient. With this slightly larger subgroup, we have only a third of the students that are proficient, so about 33%. And you can see with the red circles, here's 40 students here and 10 students here. These are the 50 students who are not proficient. Our largest subgroup happens to have everyone that is proficient. What's going to happen in this system is, instead of weighting this largest subgroup based on 190 students and weighting the smallest subgroup based on 30, we're going to equal weight each of the students. Therefore, you're only going to see the equivalent of 30 students being in each group. Now, for this center group, it maintains the same proficiency. 33% are proficient. We just ignore this half of the students. However, for my largest group that had 100% proficient, we actually do what's called a proficiency capping. So what MDE is doing is they're ignoring a third of the proficient students if the target was set at 67%. So in this fictitious example, the target was 67%. So the outliers that are below the target do not get adjusted, but the outliers that are above the target are adjusted back down to the target. And when we do this type of mathematics and we equal weight and we cap proficiencies, what look like 82% of students proficient actually comes out to be only 55% of students proficient. To demonstrate a little bit more about what that looks like, going back to our sample data, we have 51% here that is below my target of 60, and I have 71% here, which is above my target of 60. So instead of counting this as being above the target, we cap the proficiency at 60% and say that they met 100% of the target, or they had 60% proficient. So then we equal weight the 100 with the 85. And if we have some that are 0, we would weight those with 0. Of course, remember that we don't actually include anything that does not have at least 30 students. But by equal weighting these, what happens is the lowest outliers have a significant pulling your percent of your target down. But your higher outliers that are above the target are suppressed so that they cannot pull the average up. I think for the most part, people are not going to notice a lot of these business rules that were integrated into this because, again, the system's fairly generous by not reporting the 51% proficient, but instead reporting that 85% of the target, which was set at 60, met the target. So we are inflating these percent proficients, but we're also doing some really odd mathematics by weighting the content areas according to the number of students, but equal weighting the subgroups and not treating the subgroups according to the number of students. Again, just as a review from the first session, anything that has at least 30 students that should have been tested will be averaged over here on the right hand side. Anything that has more than 10 will be reported when this is publicly released. Anything with less than 10 will be suppressed. And each of these scores are equally weighted, not weighted by the number of students in the subgroup, to get the overall 74, which ends back up on our overview page for the summative proficiency of 74. Given the second highest weight, to then get a weighted index where we add these up to get our overall school index. I hope this was helpful, and on the next video we'll dive into the growth component.